All right, let's talk about the future. We're going to break down NVIDIA's new Blackwell architecture and what it really means for computer graphics. And trust me, it all kicks off with one truly mind-bending claim. So let's just start with this. This single quote from NVIDIA. It's kind of the key to everything. We're talking about a complete revolution in how we make and, experience digital worlds. A world where what you're seeing on your screen isn't just drawn. It's literally thought into existence by an AI. That's a huge deal. Okay, so what in the world does that actually mean? Well, it's this concept called neural rendering, and it's a total game changer. See, instead of doing things the old way, meticulously calculating every bit of light and every texture, neural rendering gets AI to do the heavy lifting. The AI can generate, it can enhance, it can even invent pixels from scratch. The result? Visuals that are way more realistic, super efficient, and just more dynamic than anything we've seen before. And I really want to stress this. This is not just another incremental update. We are talking about a fundamental ground-up shift. This is about creating experiences that are genuinely emergent, where game worlds can actually surprise you, where characters can react and adapt to you personally. It's about making everything feel, well, more alive.
So the big question is, how did we even get here? I mean, a leap like this doesn't just happen overnight, right? This moment has been almost 2 decades in the making. It's the result of this long, steady march of innovation, with AI research and GPU hardware evolving hand in hand. And this timeline really tells the story perfectly. You can see the clear progression. It all kicks off back in 2006 with CUDA. That was the thing that basically unlocked GPUs and turned them into powerhouse processors for more than just graphics. From there, you see how every big AI breakthrough drove a new hardware innovation. Huge models like BERT come out, bam, NVIDIA creates Tensor Cores to handle the math. ChatGPT changes the world. Well, now you need more efficient ways to handle data, so you get FP8. It's this perfect feedback loop that leads us straight to Blackwell, an architecture built from the ground up for this new era. Okay, so now for the fun part. Let's get under the hood and really see what makes this Blackwell architecture tick. What's the new engine that's actually powering this whole revolution? So when NVIDIA's engineers sat down to design this thing, they had a pretty tough checklist. 4 huge goals. First, optimize for these brand new, crazy demanding neural workloads. Second, figure out how to slash the memory needed to run them. Third, and this is a big one, make sure all this AI stuff doesn't mess up your graphics and make your game stutter. And finally, do all of that while being super energy efficient. No small task, right? The key to pulling this off, the real breakthrough here, is the new 5th generation Tensor Core, and its secret weapon, a new data format called FP4. The best way to think about it is like a super specialized, highly compressed language just for AI. It's incredibly compact, which means it's also incredibly efficient, letting the GPU just rip through AI calculations way, way faster than before. And when I say faster, I mean the efficiency here translates into just staggering power. We're talking 15 petaflops of AI compute. Let me just put that in perspective for you. That is 15,000 trillion calculations every single second. It's just an astronomical leap. But raw power is only half the story. Look at what FP4 does to memory usage. It's insane. To run the exact same AI model, it needs less than 10 gigs of VRAM. The older formats, they needed over 23 gigs. So you're freeing up a ton of memory that can be used for other stuff, like better textures, more complex game worlds, all the things that make games look amazing. And here's the real payoff. This is the so what. Because it's using so much less memory, FP4 delivers more than double the performance. You heard that right, twice the image throughput. And the quality is just as good. It's the classic doing more with less, but on a scale that's just massive. Okay, so you've got all this AI power, but how do you actually use it while you're playing a game without everything just grinding to a halt? Well, that's where another brand new piece of hardware comes in. It's a dedicated chip called the AI Management Processor, or AMP for short. Think about how it used to work. You're running a game, and maybe some AI assistant is running in the background. It was like a digital traffic jam. Both of those tasks are fighting for the same GPU resources, and the result? Stutter, lag, just a really inconsistent, choppy experience. Super frustrating. But now you have the AMP, and it's basically the ultimate traffic controller. It's smart. It knows that the graphics for your game are time sensitive. They have to hit your monitor's refresh rate perfectly. So it prioritizes those. And then, in all the little gaps in between, it seamlessly schedules the AI tasks.
The result? Every single frame is perfectly smooth, perfectly paced. It's just flawless.
And of course, all this incredible processing power needs to be fed, and it's being fed by the world's fastest graphics memory, GDDR7. It's got a much more efficient way of sending signals, which means you get double the data rate, and it's twice as energy efficient as the last generation. Long story short, those hungry AI cores are never, ever starved for data.
Okay, so we've talked a lot about the tech, the specs, the how, but let's get to the crucial point. What does all of this actually mean for you? For the games you play, for the apps you use every single day? For gaming, honestly, the promise here is transformative. Yeah, of course, we're talking about absolutely gorgeous, hyper-realistic visuals and buttery smooth gameplay, even when you crank every setting to the absolute max. But it goes so much deeper than that. Just imagine an AI in a game that actually learns from you and adapts to how you play. Or picture game worlds filled with thousands of AI agents, each one thinking for itself, creating these completely unpredictable, emergent moments. That's the future we're talking about. And hey, this isn't just for big desktop rigs. All that efficiency we talked about, it has a massive impact on gaming on the go. For laptops, for handhelds, Blackwell can literally cut the GPU's power use in half. What does that mean for you? It could mean doubling your battery life while playing high-end games. We're finally making top-tier portable gaming a real practical thing. You know, what's really incredible about all this is how it scales. This isn't just one chip for one thing. The same core Blackwell architecture that's in a gaming card is also the engine powering those giant racks of GPUs in data centers and in the cloud. It's built to work everywhere. And for the professionals out there, there's this really cool feature called Universal MIG. That stands for Multi-Instance GPU. And what it does is pretty wild. It lets you take a single, super powerful RTX card and basically slice it up into several smaller, totally independent virtual GPUs, and each one gets its own dedicated slice of the resources. So why would you do that? Well, it means you get predictable, guaranteed performance if you have multiple people or multiple apps running at once. Look at this example. If you run 4 copies of a game using MIG, it is 60% more efficient than just having them all fight for resources the old-fashioned way. That's a massive gain in how much work you can get out of one card. So when you step back and look at the whole picture, you see an architecture where every single piece has been designed for this new era. You've got the 5th-gen Tensor Cores cranking out an unbelievable 4,000 trillion AI operations a second. You've got the 4th-gen RT Cores for those jaw-dropping ray-traced visuals. And you've got the world's fastest memory feeding the whole beast. Every single component is laser-focused on making neural rendering a reality. So let's wrap this up. Blackwell? It's so much more than just a new chip. It's one single scalable architecture that's going to power everything from your gaming laptop to the entire cloud. It is the engine for neural rendering, this incredible fusion of AI and graphics that's going to build worlds we can't even imagine yet. Put simply, this is the foundation for the next era of computing. And that really leaves us with one last kind of provocative thought to chew on. As this tech gets better and better, and AI starts creating more and more of the digital spaces we spend our time in, you have to wonder, right? Where does reality end and the rendering begin?